Okay, so last time I started with some basics plus thing about functions, and now I would be discussing some advanced topics and some new introduction in the standard. Okay, so I would be skipping the function overloading part. I forgot to mention that on the first slide of the last video lecture. So that is also going to be skipped. Okay. So I would make all the important comments on your function overload. So let's start. First of all, we would see how we declare function in the new standard. Okay. So there are two methods of doing this. Either you can use trailing return type, or you can use declare types for declaring function. Okay. So declare type you may have heard earlier if you have seen my videos. Declare type is something which in which you just feed an expression, and it would return you the data type of what the expression is evaluating to. Okay, so that is what basically the declare type is, and trailing return type is something which is new, and it is based on your auto type. Okay, so let's see how we are going to implement this on the code. Okay, so first of all, we will see this complicated function declaration over here. The data type over here is of integer, but you can see there is something written in subscript over here also. So what we are going to first of all try to comprehend this function, because we have learned earlier how to do this thing. Okay, so first of all, the approach we would be following for doing this would be moving from inside to outside. Okay, so first of all, we see the inside part. We see the function name over here, which is func, and then in the parenthesis you can see we have the variable, the argument types of this function. Okay, so moving on the left hand side, we can see that this is a pointer. Okay, so now moving more towards the left, we can see that the base type is that of an integer, and moving on the right side, we can see that this is an array. Okay, so what we infer is that this is a function whose return type is a pointer to an array whose size is 10. Okay, so this is what we are inferring from reading this declaration. Okay, so to simplify this thing, we can make use of trailing return types. Okay, so in trailing return type, what we do is that we don't specify the return type ourselves. We would use the keyword auto over here, and then we would write your function name and whatever argument there is, and then on the right hand side of this arrow operator, we are going to write the type a function is going to return. Okay, so the type is a pointer to an array, so we have written that over there. Okay, so this is a way in which you can simplify the declaration of your function. Okay, now secondly, moving to your declare type. In the case of declare type, as I have told you previously also, whenever you pass an array to a declare type, it processes it as an array only. Okay, instead, if you use the same thing on an auto type keyword, then in that case what we get is a pointer. Okay, not an array. So the declare type processes an array as an array only, and it would not process this thing as some point. Okay, so the the processing which would be done would be an array, not pointer. Okay, so it processes the this thing as an array. Okay, an array having data type integer, and then it moves on your right hand side, and we have made a star over there. So what it implies is that this function, the return type of this function, is a pointer to the data type that declare type has evaluated. Okay, so what it has evaluated uh, is your array. So the return type of this function is going to be a pointer to an array. So this is another way of simplifying your code and making it look more neater. Okay, so next we move to your default arguments. Okay, so there are two important comments I want to make on function overloading. First one about your declaration, and second about the initialization of your parameters. Okay, so uh, your multiple declarations of the same function are possible for different arguments. Okay, so this is the first comment I want to make, that you can make multiple declarations of same functions, and uh, whenever you are making multiple declarations, then in those declarations you can initialize the value of your parameters, of different parameters. You can initialize with default values. Okay, so I would be showing you a code and then explaining you this thing. Okay, so if you see this thing, then this is a function which has a return type of a string. Okay, and if you look at the parameters over here, then you can see there is a parameter of type. Okay, I have not mentioned the variable type over there. Okay, so this should be an integer. Okay, this should be an integer. Okay, let me just correct this thing. Okay, so there are three arguments over here of type integer and character respectively. Okay, so what you can see is that uh, okay, I made some mistake again here. Actually, these have been declared previously. So this was just a code I was taking from the book, and these have been declared previously using your some type. Okay, using some type conversion, like they have written something using sz, using sz equal to your integer, and then not exactly integer, they have written something like size type. Okay, so it is uh, present there in certain libraries, and they have used that directly. Okay, so sz is a type over here. Okay, so there is nothing to be confused about this. So sz is a type, and if you see this function declaration, then you can see that on the right most side we have declared your default argument, and then again we are declaring this function, and we have used we have initialized we have defaulted the argument type with new values. Okay, so this is something which is perfectly valid. Okay, so this is not any scenario of multiple declarations. The code that has been written is perfectly valid. However, if it would have been something like this. Okay, let me just show it. If I it what I will copy, if it would have been something like your char, and then you have written star over here, then this would have been an error. Okay, so this would have been something which would have been an error. Okay, so multiple declarations are possible in which you are adding something to the function. Okay, but the same thing, the same argument type, it should not be defaulted again. Okay, and as goes with overloading, first of all, the right hand side the function, the arguments which are on the right hand side inside the argument list, they must be defaulted first, and then you would be moving towards the left hand side. So that is the thing which would hold here also. Okay, so first of all, you would declare your arguments on the right hand side, then only you would move on to the left hand side. Okay, so the next comment that I was making was on your initializers. Okay, so the parameters of a function can be initialized with variables. Okay, so you can use variables and sometimes even functions for initializing your parameters of your function. Okay, so the variables, obviously they must not be local to your function only. The scope of the variable must be visible to the function. Okay, so this was the second important comment that I wanted to make. Okay, now moving on to your constant expression, const expression. Okay, so this is something which is quite interesting. So const expressions, these are some these specifies that the value of variable or function can appear in constant expressions. That is the expression that can be evaluated at the compile time. Okay, so if you use this word, so if you use this word, then it would imply that the processing part of that function would be done before before the program is getting executed. Okay, so at the compile time only, those functions would be you're evaluated, not during your program run, and what the function would be returning before the compile time. Okay, so this is something important, and this keyword, it can be applied while defining your normal variables, but it is much more useful in the case of your function. Okay, so let me again show you some example of using const expressions. Okay, so as you can see over here, this we have defined a normal variable of type integer, and then we are trying to use this integer for defining your array. Okay, so this is something which is a template type, and you must remember that whenever we are declaring some template, then whatever goes inside these angular brackets, that must be something which is a constant expression. Okay, so that must be something which is known to your compiler before at the compile time only. Okay, before the program is running, the compiler must know what is going inside these angular brackets. Okay, so we are trying to use your integer type for assigning for declaring an array which has the size of n. Okay, so the compiler would show an error over here because n is not a constant expression, and thus it is not evaluated at the compile time. Okay, so how can we fix it is by using your constant type. Okay, so we could if we use constant types, then the constant is something which is evaluated at the compile time only and not during the program run. So this would become a constant, and then we can pass it to your template type. Okay, so another important thing here is to note that constant type is your constant expression. Okay, so these are something which are evaluated at the compile time. Okay, so instead we could have just added const express over here, and we could have told the compiler that this is a constant expression, although it would know it automatically because we have written const in CNE code. And also instead of using your const, we would have written this also. Okay, so all three of them, these are perfectly valid. Okay, so all three statements, they are telling the compiler to evaluate these expression before your program runs. Okay, so next, now we are done with your constant expression for your variables. Okay, so the main purpose of using constant expression is for your function types. Okay, so in case of functions, you can define functions which are evaluated before the program run. Okay, so this can be done by using your constant expression variable. Okay, so first of all, you will see this. Okay, so const expression functions. So these are the functions which are evaluated at the compile time and thus can be used in template type since their value is known. Okay, but there are some rules. These must satisfy some criteria. First of all, the return type and the parameters that are used, these must be of a literal type only. Okay, so the value which you are returning must be a literal type. That is the value of whatever the variable is or whatever you are returning. It must be known to the compiler at the compile time only. Okay, then only it's obvious that the compiler would be able to evaluate the function at the compile time. Okay, so if you don't know some value before you are compiling, before you are running the code, then how can you make the function constant or return a value which you know. Okay, so that's why the return type and the parameters of the function, these must also be of a literal type. Okay, and secondly, only literals must be present in the function. Okay, so this is also something which seems obvious because we want to know everything at your compile time. Okay, so we must also provide all the information which is known at the compile time. Okay, so we would see examples for this. So this is a good example: const expression and new sz function return 40. Okay, so a simple and plain function uh, which can be said to be a constant expression as it is only returning a literal type. Okay, secondly, if using your constant expression function, we can also declare your variables which are a constant expression. Okay, so here is where constant expression comes a bit handy. Okay, so you are not declaring the function to be a constant type, but you are declaring this expression to be constant. Okay, so in the future, foo can change your change value. Okay, so if you had written something like this constant, so that in that case, foo might foo would not be able to change the value in your future. And also this thing may or may not have been a constant expression if the function on the right hand side was not your constant expression. Okay, so in this case the function on the right hand side is a constant expression. So this whole expression can be treated as a constant, and thus we have the value of the foo at your compile time only. Okay, so before the program run, we know the value of foo. Also, if you see now, this function, this can be directly used in your template type. Okay, so you can use new sz function in your template type like in array. Okay, so you can place the value of new sz function uh, here instead of the cl. Okay, obviously this thing has to go below these functions to work. Okay, now moving on to presentation. Next, we see your pointer to functions. Okay, so this is also a very miscellaneous concept, and this is not used in your general programming. If you have just started doing programming, not started, even if you are at intermediate level and you are not developing things, then you won't be requiring pointer to functions. Pointer to functions, these are very much more useful in case of development, because it allows you to pass functions as pointers and return the functions as pointers. Okay, so we would be discussing this thing now. So a pointer that denotes a function rather than an object. Okay. So the pointer to a function, it denotes your function. Okay, not instead of denoting an object. Okay, so all the pointers that you have seen till now, they denote an object, not a function. But this type of pointer, it would denote an object, a function, not an object. Okay, a function's type is determined by its return type and type of its parameters, not its name. Okay, so this is something which is also basic. Whenever you are denoting the pointers to an object, then in that case the base type of the pointer is of the type of data type. Okay, so uh, uh, the type of the pointer is thus determined by seeing the data type, uh, which has been written before that thing. Okay, so if you are writing something like this int star p, okay, and if you are writing something like this int star r q, okay, so both these pointers p and q, they would share a common data type of type integer. Okay, so we can say that these functions are somewhat equivalent, and thus we can apply equality p equal to q, we can write, and those things. Okay, so the functions type, but in case of the function, the type is determined by the return type of the function and the type of its parameters. Okay, not the name of the function. Okay, so if we see these two functions, f int comma int, and just your say regular f function. Okay, and we see these two functions. So these two functions, these are obviously your overloaded functions. Okay, so they are having a varying number of parameters, and their name is same, but the type of these two functions, these are entirely different. Okay, so a function pointer, it would discriminate between these two functions. Okay, and also it depends on your return type also. Okay, so these are the two things that you must keep in mind, that return type is important and the type of its parameters is important, not the name of the function. Name is the least important thing for the function. Okay, thirdly, when we use the name of a function as a value, the function is automatically converted to a pointer. Okay, so if you would pass your function to another function, okay, like for instance, we create another function pf. Okay, so these two are regular functions over here that I have written. Okay, these are not your pointer to function. So if I pass these functions to say this function int, and then I write f over here and function. Okay, so this function is going to be passed over here. Okay, and what it would be passed as is as a function pointer. Okay, it would be passed as a function pointer, not your regular function. Okay, uh, So this is very much similar to your array. Uh, uh, if you ever pass an array to a function also, then the array is passed as a pointer, not as your regular array. So here also this function, it is getting converted to a function pointer, not directly your function. Okay. And fourth important thing is that type aliases, these can also be employed for using a function. Okay, so we would see all these four things in your code. Okay, so next, moving on to your code. So first of all, we would see that how we declare your function point. Okay, so we write your data type on the left hand side, and then we write the function name inside, and then this separate this parenthesis over here, it is something which is important. Okay, so if you wouldn't have mentioned your parenthesis, then this would have represented uh, would be a function that is returning a pointer to a bool type. Okay, so it would be representing that. Okay, so this is the way you are going to declare your function point. Okay, so now next we assume that we have a regular function already defined and declared, length compare. Okay, so we can assign a function pointer to another function just by equating the name of the two functions, the name of the function with that of the function pointer. Okay, so pf equal to length compare, if we write over here, then this function pointer, it would be pointing to your function only. Okay, alternatively, if you want to draw something, some parallels between pointers to object type and function type, then you can also do it by using your ampersand and then writing length compare. Okay, so both of these things, they are equivalent. Okay. Okay, so another comment that I made was that whenever you pass a function, then it is automatically converted to your function point. Okay, so here we are trying to pass your function length compare, and what it would be converted to would be your function point. So basically, if you would like to see what exactly is the use of a function pointer, then uh, it is extremely useful in the case of your generic programming, especially in the C language. Okay, so in the C++, we have template and those things, so we can do generic programming in multiple ways, but in the case of C, templates are not present, so you can use these function pointers for doing generic programming. Okay, so how exactly are we going to do that is, first of all, we would declare your function pointers. Okay, and then, so it's not exactly that important that you declare a function to a pointer. Okay, it's optional declaring this function to a pointer. But what the basic idea over here is that instead of using this length compare function, you can instead, supposedly, you want to make a function for sorting. Okay, and you want to implement it generically. Okay, so then you can pass a function as a parameter to this function. Okay, and that function can be either a small function or a large function. Okay, so by passing these functions, you can ask your sort function to do the sorting in your increasing order, or the decreasing order. Okay. But one important thing is that if you are passing the small function and the large function, the parameters that it must be taking must be equal. Okay. So the function type in both cases should be the same. Okay. So you can see the use over here, that by using your function pointer. Okay, by using the concept of function pointer at this point, we can use your function generically in the C language. Okay, so next, the function. So next, we would see how you can use type aliases for declaring a function. Okay, so type def is something which we commonly use. Okay, though it's of old standard. Okay, so you can use type def, and then you can mention the return type of the function. Okay, and then the function name and the type of parameters that it would be taking. Okay, so this is not something which is very much interesting. Okay, it is not something which is very much simple to write, and very much intuitive. So we would be seeing your other type. Okay, so if you have written this func constring ampersand constring ampersand. Okay, so if there is some equivalent function above which has been declared. Okay, so it's important that the function must be declared, and then you can use this func as an alias to that function. Okay, so say that function's name was pf. Okay, and then you are using func instead of using the function name pf. Okay, so both pf and func, these can be used for calling that single function. Okay, so next we see a more intuitive way of doing this by using your type def. Okay, so we have your length compare function, and we have used declare type over here, and then your func2. Okay, so using this, we can write a similar alias name. Okay, so declare type, this would be uh, inferring from whatever is written in the parentheses, the type of the function, and then you can use this to name your other function. Okay, so using type aliases also, you can make your pointer to function type also. Okay, so as you can see, type def bool start func p, okay, whatever this thing is, this is your usual way of making aliases. Okay, so what the focus here is, again, on the type of the function. Okay, not the name of the function, and you can use this for making your alias of your length compare of a pointer to a function. Okay, so this pointer to a function, you have an alternative name for using it. Okay, next, a more intuitive way would be by using declare type. Okay, and then we write length compare. Okay, so length compare extracts the function type, and we write here star func p2. So this denotes that func p2, it would be a pointer to this type. Okay, so these are your two ways of declaring a pointer to a function type. Okay, so another interesting way would be by using your keyword which has been introduced in the new standard. So you can write using pf equal to int star, okay, whatever type you want that alias name to have. Okay, so if you write this thing, then directly you can use this for declaring your function types. Okay, so this is something interesting. Okay, so I had to use that in the next slide. I discussed that earlier. Okay, so we are going to see some similarity of your functions with that. So there is this basic similarity that whenever you pass your array into the function, then it is as an argument, then it is automatically converted to your pointer. Okay, so similarly, whenever you pass your function as an argument to another function, then then also it is automatically converted to your function, your pointer to function type. Okay, and then secondly, when you return from your function, then in that case also if you return an array, then the is returned as a pointer, okay, not as an array. Okay, so if you write something like return and then your array name, supposedly the name of the array was ar, and somewhere you had declared it as ar, okay, 10 supposedly. So this what you would be returning, it would be a pointer to this pointer, okay, which would be pointing to the first element of the array. Okay, so similarly in the case of function, whenever you return from the function, then you return a function pointer, okay, not exactly a function. And lastly, using declare type is also very much convenient in the case of your arrays also. So you can use it in the function also. So I had explained you this thing using pf equal to int star. Okay, so similarly this method is very much convenient when you are defining functions of type of the type of array. So you can use it in declaring your functions which return a function pointer also. Okay, and thirdly, and also you can use your declare type also to get a function pointer. Okay, so the declare type, if you would use it on a function, then it would reduce it as a function only. So you have to use this additional star present here to tell the compiler that whatever is being returned is a function pointer. Okay, so if the star is missing, then in that case it is going to be n. Okay, so this star must be present because whenever the function would be returning, it would be returning a function pointer, not an actual function. Okay, so by this we come to the end. Okay, so thank you for watching, and next time what we are going to discuss is the class type, and I have uploaded this PPT on the blog. I would be giving you the link below, and some important topics, whatever the references that I took from some good sites. Okay, so you can go through those things also, and of course the chapters 5, 6, 4, 5, 6 of the book also. Okay, so thank you.